So let's start off with exercise 3.4 trigonometric functions. Chapter 3. So what's the first problem? We'll just see. Find the principal and general solutions of the following equations. So question 1, tan x is equal to root 3 we having. The solution part, how do we do? We'll just see. So solution of this, here we are having tan x is equal to root 3. So you have to remember some formulas for general solutions. What are those general solutions for each trigonometric ratio? We'll just see. So here the general solution for, if you remember, for sine, cos and tan, you can it's the same for cosecant, secant and cot. I'll tell you how. So because general solution, how to write the general solution. Suppose we are having sin x is equal to sin y. So general solution for this and for cosecant it's the same. For cosecant also you'll have the same general solution. So when you're having sin x is equal to sin y, the general solution for this is x is equal to n pi plus minus 1 to the power of n into y, n belongs to z. This is the general solution when sin x is equal to sin y. Next, we have second one is cos x is equal to cos y. This and even secant is the same because the inverse of cos is secant. So general solution for this is equal to x is equal to 2n pi plus or minus y, where n belongs to z. So this is the general solution when cos x is equal to cos y, and even for secant x is equal to secant y. Next, last one we have tan x is equal to tan y. Now this is the same for as cot value. Even the trigonometric ratio, cot is also having the same general formula, general solution. So x is equal to n pi plus y, where n belongs to capital Z or set of integers. So these are the general solutions for the given trigonometric ratios. That is for sin x is equal to sin y, cos x is equal to cos y, tan x is equal to tan y. We have these as the general solution. So wherever we get these, we'll be using these formulas. So going into the first problem, you are having here in this question, find the principal and general solutions of the following equations. Here tan x is equal to root 3. So while doing the problem, I'll be telling you all how to find out the principal value. General solution is already there over your side. How to do that also we'll be seeing when we are doing it. Now we are having tan x is equal to root 3. Tan x is equal to root 3. Where do we have tan x is equal to root 3? Tan pi by 3. That is tan 60 is equal to root 3. Right? So now here you are having tan x is equal to tan pi by 3. Right? So therefore if tan gets cancelled, you are getting x is equal to pi by 3. So this is one of the principal solution of the following equation, that is tan x is equal to root 3. In one more place also you will get this principal value. Where do you have now, when you are considering this, you know, the x-axis, y-axis, you have all the 4 quadrants. This is all silver tea cups. So in this all are positive, you know that. Whenever you are taking here, so again you are having 2 pi over here. This is pi equal to pi and this is equal to 2 pi. So here we can consider this as 2 pi plus theta or 2 pi minus theta. So over here in these 4 quadrants, this is the first quadrant, this is the second quadrant, this is the third quadrant. You can very clearly see that in the first quadrant, when you are having 90 minus theta, all of the trigonometric ratios are all positive. The second quadrant, that is 90 plus theta or 180 minus theta, you are getting it as equal to all only sine and cosecant will be positive over here, and in the third quadrant tan and cot will be positive, and in the fourth quadrant cos and secant will be positive. So you know that these are in that way we remember what is this all silver teacups. So when we remember it in this way, you also know that tan of pi plus theta is equal to tan theta, isn't it? So and you have in this third quadrant that tan is positive. So because your root 3 is positive, you can also write this as tan x is equal to tan pi by 3, which also can be written as tan of pi plus pi by 3, which is equal to tan of 4 pi by 3. So therefore if you are cancelling here, tan x is equal to, we got it as tan 4 pi by 3. So therefore this is implies x is equal to 4 pi by 3. So therefore the principal solution which you are having here is, principal solution is x can take values pi by 3 and 4 pi by 3. Now going into the general solution. How do you find out the general solution? We'll see general solution. Now you are having tan x is equal to tan pi by 3. We are taking the first value itself. We are not taking the second one. We'll take the first one itself. So tan x is equal to tan pi by 3. What is the formula we are using for this? We are going to use this formula. That is x is equal to n pi plus y. Now y is nothing but pi by 3. So therefore the general solution, we'll see we are having tan x is equal to tan pi by 3. So we can use tan x is equal to tan y formula, which is equal to tan x is equal to n pi plus y for n belongs to z. So our y is equal to nothing but over here y is equal to pi by 3. So therefore tan x is equal to n pi plus pi by 3 or n belongs to z. So this is the general solution for the given problem. Now going into the second problem, you are having secant x is equal to 2. So solution part over here. So in the solution part over here, you are having secant x is equal to 2, right? So we can use what is the general formula for cos x is equal to, general formula is cos x is equal to cos y. We have x is equal to 2n pi plus or minus y, n belongs to z. This will be the general solution. What is the principal solution? We'll see first. So therefore here principal solution, where is you are having a positive 2. So therefore secant x is equal to secant pi by 3. You know that secant pi by 3, you have to remember all the values over here. If you remember sine, tan and cos, that's enough. So you are having here secant cos 60 is equal to 1 by 2. So reverse of that will be secant x, that is secant 60, which is equal to 2. So you are having secant x is equal to secant pi by 3. Therefore here you are having, if secant will get cancelled over here, you are getting x is equal to pi by 3. Now again when we are taking these 4 quadrants over here, whenever we are considering this, you are having again all silver tea cups. So now here in which quadrant is this secant positive? It is positive here, that is 2 pi. If we take 2 pi minus theta part, that is here cos and secant both are positive over here. So therefore we are taking in the fourth quadrant, we can write it as 2 pi minus theta is again tan secant of 2 pi minus theta is secant theta again. So therefore you can write this as secant of 2 pi minus pi by 3 is again equal to secant pi by 3. So this is again written in this way. Therefore this is equal to, you can write this as secant x is equal to secant, if you are taking a LCM over here, you are going to get it as 6 pi minus pi, that is equal to secant of 5 pi by 3. So therefore your secant x is equal to secant 5 pi by 3. So secant will get cancelled. You are getting x is equal to 5 pi by 3. So the principal solutions which we are having here is, principal solution is pi by 3 and 5 pi by 3. This is the principal solution which having. What is the general solution? We'll see. General solution is, I told you for cos and secant it's the same. So therefore secant x is equal to secant y, means it is equal to x is equal to 2n pi plus or minus 2n pi plus or minus y. N belongs to capital Z. So here you are having secant x is equal to, we'll take the first value itself, that is pi by 3. So therefore x is equal to 2n pi plus or minus pi by 3, since y is equal to pi by 3 for n belongs to Z. This is the answer. Cot x is equal to minus root 3 means you can write this as minus cot of pi by 6, because cot pi by 6 is nothing but cot 30, which is equal to root 3. So now we are taking this quadrant. So here you know that in the first, second, this is the first quadrant, second, third, fourth, when you're taking all silver teacups, it is positive only in the third quadrant. In the second and in the fourth quadrant we are having it is negative. So we can take this as, this is pi and this is 2 pi, we know that. So we can take it as pi minus theta, and here you can take it as 2 pi minus theta. So therefore cot x is equal to, it is negative in that part because we are getting a negative sign, therefore we have to take that. So therefore it is cot of pi minus pi by 6, which is equal to cot of 6 pi minus pi, which is equal to cot of 5 pi by 6. So therefore cot x is equal to cot 5 pi by 6. This is one principal solution which you got. X is equal to 5 pi by 6. Next one is, we are having one more, cot x is equal to, it is negative at which more point? It is negative at cot of 2 pi minus pi by 6. So which is equal to cot of 12 pi minus pi by 6, which is equal to cot of 11 pi by 6. That is cot x is equal to this, therefore cot will get cancelled. So we are getting x is equal to 11 pi by 6. So therefore the principal solutions are 5 pi by 6 and 11 pi by 6. These are the principal solutions which you got. Now what are the general solutions? We'll see. General solution is, for tan and cot it is the same. So general solution you are having cot x is equal to cot of y, that is cot x is equal to cot of 5 pi by 6. So cot and tan has the same formula, therefore x is equal to n pi plus y. So x is equal to, for n belongs to Z, n is equal to n pi plus 5 pi by 6. So n belongs to Z. This is the general solution. So here you have to see if you are getting a negative value, whether which quadrant it lies, and according to that we have to take the value and do. You know that in the remaining over here, when you are taking, if it can be written, the second quadrant can also be written as tan pi by 2 plus theta, but tan pi by, here when you are taking cot pi by 2 plus theta, it becomes cot. So therefore if you are taking only cot into consideration, you have to consider only these values, that is pi minus theta, because tan pi minus theta and tan pi 2 pi minus theta is only, you are going to get it as cot or tan, whichever trigonometric ratio we are taking, you will get back the same trigonometric ratio. So next, going cosecant x is equal to minus 2. So in which place is which value we are going to get this value, that is cosecant x is equal to minus 2. Over here you will be getting it in which this one, it is equal to sin pi by 6, that is, I am sorry, cosecant pi by 6. So solution part, if you go, you are having cosecant x is equal to minus 2. It is negative. So when you're taking the quadrants over here, you know that where is sign negative over there? This is here first all silver tea cups. So in the second one only it is positive. In the third and the fourth, that is pi plus theta and 2 pi minus theta, it is going to be negative. That is in the third and the fourth quadrant. So therefore here you are having cosecant of x can be written as minus of, where are you getting 2 for this? 2 value, for which value you are getting cos of cosecant of what is equal to 2? Cosecant of pi by 6. So this is equal to minus cosecant of pi by 6, but it's a negative value. So we have to consider cosecant of pi plus theta, that is cosecant of pi plus pi by 6. So therefore here cosecant x is equal to cosecant of pi plus of pi by 6 will give you minus cosecant of pi by 6. You will get back this previous one. So therefore from this you can write it as cosecant of 7 pi by 6. So cosecant x is equal to cosecant 7 pi by 6. This is one answer which we got for the principal solution. So x is equal to 7 pi by 6 is 1. The next one where we are getting negative, we are getting it as cosecant x is equal to cosecant of 2 pi minus of pi by 6. In that also, in the fourth quadrant also, it's negative. Therefore cosecant of 12 pi minus pi divided by 6, which is equal to cosecant of 11 pi by 6. So therefore here x is equal to cos x is equal to cosecant x is equal to cosecant of 11 pi by 6. So this two will get cancelled, which implies x is equal to 11 pi by 6. So the principal solutions are here what we are having it as x is equal to 7 pi by 6 comma 11 pi by 6. Now what is the general solution? We'll see. General solution, we know that for sine and for cosecant it's the same. So therefore cosecant x is equal to cosecant of y. What is the general solution which we are having? We are having it is equal to x is equal to n pi plus minus 1 to the power of n into y. N belongs to z. So since our y over here, cosecant of x is equal to cosecant of 7 pi by 6. Since our y is equal to 7 pi by 6, x is equal to n pi plus minus 1 to the power of n into 7 pi by 6. So this is the general solution which we are having for the fourth problem. Now going into the next one. So going into the fifth problem, question 5, cos 4x is equal to cos 2x. So how can we write this? What's the solution part? We'll see for this. So in the solution we have that cos 4x is equal to cos 2x. You can write this as cos 4x minus cos 2x is equal to 0. Now this is of the form cos a plus cos a minus cos b, you can write, or cos c minus cos d. The previous videos I put it as cos c minus d and c plus d formula. So I am just writing here cos a minus cos b. We can write it even in this way. Sometimes in the question they might give in this way also. So which is equal to 2 sin a plus b by 2 into sin a minus b by 2. This is the formula which we are having. So using this formula we will write down this. So what do we get here? Using this formula we can write it as, it is minus 2. Minus 2 sin a plus b by 2 into sin a minus b by 2. So minus 2 of, it is cos of 4x minus cos 2x is equal to 0 can be written as minus 2 of sin 4x plus 2x by 2 into sin 4x minus 2x by 2, which is equal to 0. Now this can be written as minus 2 of sine 6x by 2 is nothing but 3x into sine of 4x minus 2x is sine 2x by 2, which is equal to sine x equal to 0. So now here you can write this as either sine 3x is equal to 0, or you can write this as sine x is equal to 0, right? So now here you are going to get this as, now the general solution, you know that when sine x is equal to sine y, you know what is the general solution. When sine x is equal to 0, there is a general solution which is x is equal to n pi for n belongs to z. So here this is the general solution when sine x is equal to 0. When you are having sine x, both of them, here you are having 3x is equal to n pi you are getting. So x is equal to n pi by 3. Now here also you can write this as x is equal to n pi. That is, here whatever we are having, the solution for this is x is equal to n pi, x is equal to n pi by 3 for n belongs to z. This is the answer which we are getting for this. This is the general solution for this. Now going into the next way. So in question 6, how do we do this problem? We'll see. So here you are having it as cos 3x plus cos x minus cos 2x is equal to 0. This is question 6. So how do we do this? Here again we have to apply the same cos a plus cos b formula here. So now here for which two we take first, we'll see. So given to us is cos 3x plus cos x minus cos 2x is equal to 0. So we are going to take the formula for these two first. So what we do is cos a plus cos b is equal to 2 cos a plus b by 2 into cos a minus b by 2. This is the formula which we are having. So this is equal to, we can write this as here cos 3x plus cos x minus cos 2x is equal to 0 can be written as, here you are having 2 cos of 3x plus x by 2 into cos of 3x minus x by 2 minus of cos 2x is equal to 0. So now we are going to get this as 2 cos of 4x by 2 is nothing but 2x into cos 3x minus x is 2x by 2, which is x, minus cos 2x is equal to 0. Now we are having in both of them cos 2x common. So if you take out cos 2x common, you are going to get inside 2 cos x minus 1 is equal to 0. So now we are having here either cos 2x is equal to 0 or 2 cos x minus 1 is equal to 0. So we are having one of these two. Now when you are having cos x is equal to 0, your general solution is nothing but x is equal to 2n plus 1 into pi by 2. So you have a general solution for this separately, that is whenever cos x is equal to 0. So now here you are having 2x is equal to 2n plus 1 into pi by 2, or x is equal to 2n plus 1 into pi by 4. Now next one is 2 cos minus 1 is equal to 0. Over here you are having this as 2 cos x is equal to 1, or cos x is equal to 1 by 2. That means cos x is equal to cos, where are we going to get half for cos x near cos 60, that is cos pi by 3. So therefore x is equal to pi by 3. So general solution for this is when cos x is equal to cos y, we are having it as equal to cos x is equal to cos y, we are having it as x is equal to 2n pi plus or minus y. So therefore now what are we having here? We are having here our y is equal to, here you got, if you cancel it you are getting it this. So for this only we are going to put it as y. So therefore here x is equal to, here you can write it as cos x is equal to cos pi by 3. So here we are taking y as equal to pi by 3. Therefore x is equal to 2n pi plus or minus pi by 3. So this is the answer for n belongs to z. Next, going into the next problem. What is the next problem? We'll see. So question 7, sin 2x plus cos x is equal to 0. Now you know that sin 2x, the previously we had, sin 2x, there is a formula for sin 2x. So what is that? We'll just see and then we can do according to that. So here sin 2x plus cos x is equal to 0 is given to us. So you know that sin 2x can be written as 2 sin x cos x. So I will replace this in this. So therefore you get here 2 sin x into cos x plus cos x is equal to 0. Now we can take out here cos x common in both of them. Therefore cos x into 2 sin x plus 1 is equal to 0. Therefore you can write this as cos x is equal to 0, or you can write it as 2 sin x plus 1 is equal to 0. So therefore when cos x is equal to 0, you know that x is equal to the general, you have here the general solution as equal to 2n plus 1 into pi by 2 for all n belongs to z. So now here also again you can take it as 2 sin x plus 1 is equal to 0. So you can write this as 2 sin x is equal to minus 1, or sin x is equal to minus 1 by 2. Now you know that where is this negative, or you can write this as sin x is equal to, where is it equal to, half sin pi by 6. Now when we are taking this, you know that all silver tea cups, so in which quadrant is sign negative? In the third and the fourth one. So in the third and the fourth quadrant sign is negative. So this can be pi plus theta or 2 pi minus theta, because you'll get back the same. Therefore you can write this as sine of, here you're having it as equal to sine x is equal to sine of pi plus pi by 6, which is equal to x is equal to 7 pi by 6. Or you can also write this as 2 pi equal to sine of 2 pi minus pi by 6 also you can write. Here you will be getting it as sine of 11 pi by 6. But we are going to write the general solution only for 1 over here. So what is that? We'll see. Therefore you have that sine x is equal to sine y. That means you can write it as sine x is equal to sine of 7 pi by 6, which implies that x is equal to n pi plus minus 1 to the power of n into y, which implies x is equal to n pi plus minus 1 to the power of n into 7 pi by 6 for n belongs to z. This is the general solution of your given problem, which is given. First one is 2n plus 1 by into pi by 2, and this is the second. So the solution is x is equal to 2n plus 1 into pi by 2, and x is equal to n pi plus minus 1 to the power of n into 7 pi by 6 for n belongs to z. This is the answer for this problem. Next, we'll go into the next problem. What's the next problem? We'll see. Here you are given secant square 2x is equal to 1 minus tan 2x is the 8th problem given to us. So now here you are having that secant square 2x is equal to 1 minus tan 2x. So now here, how can we write this? We know that there is a formula for this. Secant square 2x is equal to 1 plus tan square 2x. So this can be written as, the left hand side can be written as 1 plus tan square 2x is equal to 1 minus tan x. Now this 1 and 1 will get cancelled, so you can write this as tan square 2x plus tan x is equal to 0. So now here this is 2x, I'm sorry, this is also 2x. So now here this you can take out one tan 2x common from both of them. So you're going to get it as tan 2x plus 1 is equal to 0, or you're having that tan 2x is equal to 0 or tan 2x plus 1 is equal to 0. So now here you're having tan 2x is equal to 0. We don't have a general formula where we have this equal to 0. We can write this as tan 0, and at tan 0 it is equal to 0. Therefore you're having 2x, applying the general solution formula, 2x is equal to n pi plus y and x is equal to n pi plus 0. That's 2x is equal to n pi plus 0 or x is equal to n pi by 2 for n belongs to z. This is one solution. The next one you're having here, tan 2x is equal to minus 1 or tan 2x is equal to minus of tan pi by 4 is equal to nothing but 1. So where are you getting here? Again you apply this quadrants 1, that is all silver tea cups. So where all it is negative in the second and the fourth quadrant. So now it is pi minus theta or 2 pi minus theta. So therefore here you are getting it as equal to tan of 2x is equal to tan of pi minus of pi by 4, which implies that tan x is equal to tan y, means you get here x is equal to n pi plus y. So therefore this here you are getting it as equal to 2x is equal to, so from here you get 2x is equal to n pi plus, this y is nothing but 4 pi minus 1 is 3 pi by 4. So 3 pi by 4, or which implies that x is equal to n pi by 2 plus 3 pi by 8. This is the answer which we are getting for this. So this is for n belongs to z. Next, going to the, so in this problem again you are having here question 9, sin x plus sin 3x plus sin 5x is equal to 0. So over here we have to take it in a combination in such a way that you can take out common any one of them common you have to. So sin x plus sin 3x plus sin 5x is equal to 0. Now when you are adding x plus 3x by 2, you are getting sin 2x, but here you are having 5x. So if you take x plus 5x by 2, you are going to get it as 6x by 2. So sin 3x you can take out common. So we are going to take formula for this. The formula which we are going to apply for these two is sin a plus sin b is equal to minus 2 sin a plus b by 2 into cos a minus b by 2. This is the formula which we are going to apply for this. So therefore you are going to get this as it is plus only, plus 2 sin a plus b by 2 into cos a minus b by 2. So applying the formula you get it as 2 sin x plus 5x by 2 into cos of x minus 5x by 2 plus sin 3x is equal to 0. So this can be written as 2 sin of, see, x plus 5x is 6x by 2 is 3x into, here you are going to get minus 4x by 2, which is equal to cos of minus 2x, and you know that cos of minus x is equal to cos x itself. So therefore cos of minus 2x is equal to cos of 2x. So therefore this becomes cos of 2x plus sin 3x is equal to 0. Therefore you can take out sin 3x common. So you are getting here 2 cos 2x plus 1 is equal to 0. So you are getting here sin 3x is equal to 0, or here you are getting 2 cos 2x plus 1 is equal to 0. So therefore you are having a formula for this. 3x is equal to n pi, or x is equal to n pi by 3 for n belongs to z. This is one solution which you got. The other solution is 2 cos 2x is equal to minus 1. Cos 2x is equal to minus 1 by 2. Now here you are having in which cos 2x is equal to minus cos of pi by 3 is equal to half. Here in which quadrant you are having cos negative. So all silver tea cups. So in this you are having in the second and the third quadrant you are having it as negative, that is pi minus theta and pi plus theta. Therefore here you can write this as cos 2x is equal to cos of pi minus of pi by 3. So here if you continue here, cos of 2x is equal to cos of 2 pi by 3. So therefore which implies that 2x is equal to, for this if we apply the n formula, x is equal to 2n pi plus or minus y. So this is a formula which we apply for this. So therefore you are having 2x is equal to 2n pi plus or minus 2 pi by 3. So if you are bringing this to the side, you are going to get it as n pi. Okay, you bring it like this, 2 pi by 3 into 2. So 2 here 2 so which is equal to x is equal to n pi plus pi by 3 for n belongs to z. So therefore this is the general solution for this problem. N pi plus or minus pi by 3 for n belongs to z.